Hi, this is Paul Purdell with the Pipeliners website committee. Welcome to our February meeting. I'm going to do kind of the pregame show and hand it over to Gary DeLita in a second. So wanted to start off thanking our meeting sponsor, Barry O. And so we can knock out a few of the questions that we typically see. Yes, we are going to record this session. Yes, we are going to post the slides and recordings after the fact. The slides will be posted within a week. The recordings takes a little bit longer to process, maybe within the month. And the members who've joined today will automatically receive scholarship check-in credit, provided their registration email matches their profile email, and they remain on the meeting for at least 30 minutes. And lastly, please engage with us. Please submit questions and answers. We'll probably do that several times during the meeting, but definitely at the end, we'll cover all the questions. So submit your questions, and then we'll have volunteers in the background process those and get those over to our speaker. Just a little orientation on the product. Up in the top right, you should see a little control panel like the one that's on your screen now, circled in red. There's a question box, and in that question box is where you can enter comments or questions, and then that'll come to us. Just a quick reminder, the website is probably your best bet on getting information about what's going on to the with the association. So go to houstonpipeliners.net, bookmark that, and check that on a daily basis. And with that, I'm going to turn it over to President Gary DeLita to actually start the meeting. Gary?
Yes, thanks, Paul. I'd just like to welcome everyone to our February monthly meeting and hope everyone's doing well. Looking forward to a good 2021, better than 2020, we hope. And then to get things kicked off, as usual, I'd like to have everybody join me in reciting the Pledge of Allegiance. So, pledge allegiance to the flag of the United States of America, to the republic for which it stands,
one nation
under God, with liberty and justice for all. Then a couple of quick updates. Again, I'd like to thank Barry O. Construction for being our monthly meeting sponsor for today's meeting. If any of your companies would like to sponsor a monthly meeting, just let one of the officers know, mainly Paul. He could get you set up. Also, real quick on looking forward to the next few monthly meetings in March. We do also plan to be virtual during the lunch hour on Monday, March 1st. And then we are targeting a return to live monthly meetings on Monday, May 3rd at Norris Center. As you know, historically, we don't have a meeting in April. We have our usually have our golf tournament race shoot around that time. So anyway, hopefully we can all see each other in May. And I guess next thing, everybody's aware that we're just in the middle of our scholarship application season. In fact, that just launched last week. So invited Barb Powell to come and say a few things, give everybody an update on the scholarship process, where we're at, and then Barb's going to stay on and answer any questions you might have. So I'm going to turn it over to Barb right now and let her speak about the scholarship process for this year. Thanks, Barb.
Thanks. Appreciate that. And if any of you already have questions about scholarship process or your students, go ahead and type those to the Q&A section on the side here. So maybe I can answer those at the end of my my little notes that I'm going to share with you guys. First, we're going to talk about some dates. The scholarship application opened last Tuesday, January 25th. It closes on February 23rd at noon. And our current interview date is, as always, the Saturday before Easter, which this year is Saturday, April the 3rd. I'll address that down in some of my notes at the bottom. You're always welcome to ask questions. I'll go to the next one, but please check our scholarship tab under frequently asked questions before contacting us, because almost anything you're going to ask us by email or by phone call is answered under that frequently asked question tab on the scholarship page. Also, one of the questions that we get quite often, and Paul, if you want to advance to that slide too, there is is a sponsor eligible? Have they attended enough meetings? You can actually go to the website page and under about us, there's a question section there, and the bottom of that section, how you can go in and check to make sure that you've attended enough meetings, which for 2020 was 6 meetings. The things that have come up this year are multiple applications. Students that are applying for a second or third time, some of the students are not going in and entering a new application, but trying to go in last year's application. That doesn't work. We're not TurboTax. We don't hang on to your info. So everyone who is applying this year, everybody needs to start a new application, even if you're a returning applicant. And when you go in and start that new application and save the first page, you'll get a code that allows you to go back in and finish your application or edit it at any time. Remember, all students must submit a transcript for every institution of higher learning that they've attended. Let's say your student goes to Texas A&M, they've attended Lone Star in the summer, then they need to send us an application, a transcript for both Texas A&M and Lone Star. Lastly, we are talking about what we're going to do about our interviews during the current COVID situation. We understand that, and have already been contacted by several parents, that some of the students have had to sign contracts with their university saying they won't travel, they won't get on a plane. So the scholarship committee feels the most important part of the application is the face-to-face interview, but we'll always put safety first. So we are having a discussion on what we're going to do about interviews this year. There may be a change. It may not be face-to-face this year. If it's changed from face-to-face for this year, it will be only for this year. When we're able to go back to face-to-face, we will have that same requirement, and there will be no exceptions to that. We will notify all students and sponsors by February the 25th of our plan for interviews or alternates to interviews. I think that's all that I have. Does anybody have questions about the scholarships?
Yes, Barbara, we've had a few questions come in. So the first question is from Rob Taylor. He wants to verify that scholarships are only open to existing college students. Current high school seniors are not eligible. Is that correct?
That is correct, because you have to be a minimum of a sophomore in college and have attended a university for at least 1 year. So even if you're classified as a sophomore when you enter your freshman, because you have either dual credit classes or AP classes, you're still not classified as a sophomore by pipeliners. You have to attend university for 1 year.
Okay. Thank you, Barbara. And the next one you may have covered fairly thoroughly, but just want to ask since it came in from Zena Barnes, is the only date for interviews Easter weekend?
Yes, and it will always be that way, and that will never change.
And then from Arun, and Arun, I'm sorry if I slaughter your last name, Bargava, what is the estimated interview duration on April 13th?
10 minutes.
All right, thank you.
10 minutes per student is what we normally do.
Right, okay. And then the next one from Matthew Close, are students/sponsors notified when their transcripts are received?
They are not notified when the transcript is received if it comes prior to the application being uploaded. We have no way of, when I get a transcript in the mail, I don't have the student's email address, current email address. I would have to go search for the sponsor's email address if I even know who the sponsor is. Some people who are sponsoring nieces, nephews, or whatever, when that transcript comes in, I have no way of tying that back to someone who doesn't have the same last name. Once the student completes their application and the application is processed and approved, if I have a transcript, I attach the transcript to the application, and at that instant, the student and the sponsor is notified that a transcript has been uploaded to the application.
Thank you, Barbara. And then the last question we have related to scholarships is the schools are supposed to forward you their transcripts. How can we make sure you have received their transcripts? I think you covered that with a question that you had there.
Yes.
That came in from
And
Hilda.
it doesn't do me any good. Yeah, it's very, wait until your student has put the application in. Please don't, we have about 155, 160 applicants. So if I get an email from every sponsor with multiple questions and multiple emails. I end up having 800 or 900 emails to answer about the scholarship process. Not that we don't answer questions that are one-off, we're happy to do that. But please wait until the student completes the application. And then if you don't get a notification within 24 hours of the application being accepted, that a transcript has been uploaded to the application, then we did not receive that transcript.
Okay, and Barbara, a question related to transcripts from Chris Knutson. Does it have to be an official transcript or is unofficial okay?
Unofficial is not okay. It must be an official transcript. Unofficial transcripts can be manipulated, but it can be an e-transcript. It can come through one of the transcript services because those, of course, are also official transcripts.
Okay, thank you, Barbara. And the hits keep coming on in. So from Brad McLean, please confirm graduate students are not eligible.
Graduate students are not eligible. Houston Pipeliners Association gives scholarships to students as a sophomore, junior, senior, or fifth year senior if you need that extra year. So each student can get a maximum of 4 years of scholarship for undergraduate. So if we don't give trade school, we don't do nursing school or PT school or freshman, as we've already discussed. So if let's say your student graduates with a bachelor's, and once they graduate with a bachelor's, whatever they're going to do after that is not eligible for a Pipeliner scholarship. Now, if your student is getting a Bachelor's of Science in Nursing, a BSN, and it's part of their original 4-year plan, then we give a scholarship for that degree, but we don't do anything after a bachelor's degree.
All right, thank you, Barbara. And it looks like the questions are slowing down, so we've got a couple more from Benton Pittman. Says, I've been told that Lone Star will not send hard copy transcripts. How should we obtain a valid transcript, and where should that e-transcript be sent to?
I get Lone Star hard copy transcripts all the time. Having said that, I don't know that I've received any since COVID. Lone Star does do e-transcripts, and there are instructions on the application on how to send an e-transcript, and also on the frequently asked questions under the scholarship tab on where to submit the transcript.
All right, and then a question from Dean Cushing. How do you know which transcript was received if multiples are being sent as part of the application process?
The student can go look at their application, and there's a tab they can look at to see what has been submitted, and it'll say, in Dean's case, Tyler Cushing transcript, Lone Star College. Tyler Cushing transcript, Texas A&M. It calls it out.
All right, thank you, Barbara. And that wraps it up for all the questions we have for scholarships. If anyone has additional scholarship questions, please go ahead and submit them. Know that we will not be addressing them now, but we will email those answers individually for anything that comes in after this. Or like Barbara said, you could reach out to the scholarship committee, but please do that after you read the frequently asked questions. Thank you, Barbara.
I have a few more announcements. Just want to give everybody an update on some of our upcoming events. I'll start off with the next one that's up is the PYP is doing a financial workshop, a webinar on February 22nd from 2 to 4 p.m. and registration's open on our website for that right now. And we've got some folks from Morgan Stanley who are going to discuss the economy and markets, and financial risk and strategies and all kind of good stuff like that. So, look for that on the website. That's our next one up, February 22nd. Let's see, PYP is also looking again at a summer bowling tournament in July. So you'll find out more about that on the website here soon. Next up, we've got our spring sporting clays at the Westside Sporting Grounds. That's scheduled for Friday, March 12th. And that registration opened last Wednesday on January 27th. And Jim said things are looking good. We have 120 teams plus or minus right now. So that's looking good. I'm not sure when that registration closes. I'm sure that's on the website. Then got word from Trey last week that he has finally nailed down a schedule for the spring golf tournament in Kingwood, and that's going to be Monday, March 29th. And he's got the registration for that this coming Monday, February 8th on our website. And then let's see, next up is the fish out, this year's 2021 fish out. Mason wants to open registration on April 19th, and that'll remain open until June 1st. That event's also going to be, as usual, the first Saturday weekend in June. So this year, June 4th and 5th, and it's going to be where it was last year at Marker 37 Marina in Corpus Christi. City of Port A still not open to large gatherings, so Mason went ahead and booked it for Marker 37 just to make sure we get on the schedule there. Let's see, what else? Just a brief update on our online education. So far, we only got 62 folks enrolled, although 6 folks have completed that first course, which is pipeline technology design. EYP can use some sponsors to help fund the next course that we're going to work on with PTEX. Really like to get that out this year sometime if we could get enough funds to do so. Then from Andrew and the membership committee, we currently have 1,570 paid members, and we acquired 41 new members just in January, so that's some good news. From the website committee, on behalf of Paul and those folks, he wants to again thank RockGuard HD for being our website sponsor, and we can take some more website sponsors too if you want to be a website sponsor. Suggest that you contact Paul. And then finally, treasurer, from Alex, in our checking account, we have a little bit over $729,000. So in real good shape right now for the upcoming scholarships. We still have, like I said, a couple more events to use towards that. And in our savings, again, a little bit over $100,000. Really, that's all I had. Wanted to get through that pretty quick and get onto our presentation. So I'm going to hand it over to Jim Hughes, our VP, and he's going to introduce our speaker for today. Thanks, Jim.
Thank you, Gary. And I just want to introduce Mr. Sid Gaudet, and he is with S Benbow Associates. He's a senior electrical engineer with them, and he's been a consultant electrical engineer since 2007. Pretty much serving the upstream, midstream, refining, power utility, commercial, and municipal markets. He has extensive experience with power system modeling software, with more of a focus on arc flash, coordination, harmonics, duct bank design, and reliability calculations. Sid also holds an engineering license in both Texas and Louisiana. And as a consultant, he's specialized in providing technical solutions to improve electrical efficiency, reliability, and safety for many of the projects he's worked across the country. Sid, we welcome you to the Houston Pipeliners as our guest speaker today. We look forward to your presentation. It's all yours.
Thank you, Jim. I appreciate that introduction. Can you guys please just verify that you're seeing the presentation?
We got it.
Excellent. So I appreciate everybody's time here. I do this presentation every now and then for if we have public webinars, and I'm gonna make this a little bit more of an overview, so it's not gonna last too terribly long. We're gonna talk a little bit today about electrical reliability in your infrastructure for any, and this is applicable across the board, whether it be municipal, commercial, industrial, midstream. Electrical reliability is very important in maintaining your processes. So today we're going to talk about a few things. We're going to talk about what reliability is. We're going to define it. We're going to talk about how we provide a reliability study. What do we need to do so? We're going to talk about how we calculate reliability, what the terms mean, and how to apply it to our bottom line. We're going to talk about using software to perform calculations, which has made things a little bit easier these days. And of course, we're going to, at the end, talk a little bit about some quick methods to improve our reliability. And Please feel free to type in some questions if you have some questions. I do like interactive presentations, and I'm happy to answer anything anybody might have to ask. So first, we're going to start with what is reliability, which reliability can mean a lot of things. And many people in the electrical world might think reliability just means, do you have power or do you not have power? That is not a complete definition. I have the definition shown in my presentation here. It's a measure of the ability of a power distribution system to deliver sufficient electrical power to a system within accepted standards and in the amount desired. There are a couple key points to that. One of them being, do you have enough power to provide for your entire operation? But also, is it sufficient power and is it within standards? Within standards is something that people don't really think too much about these days, because now we have a lot more solid state devices like VFDs to change the speed of your motors, and you have a lot of computer equipment. You have a lot of switching mechanisms which can dirty up your power by adding harmonics to your system. So the quality of power is also very important when we discuss equipment reliability. So we're going to talk a little bit about a reliability analysis. The reliability analysis, this is based on the IEEE 493, which is commonly known as the Gold Book. It's probability theory. For those of us that have talked about probability or maybe studied it in the past, probability theory has been developed and is applicable across the board for all kinds of industries. So what we care about here on the electrical side of things are really two things. How often is a component or a system going to be interrupted? And when it is interrupted, on average, how long is that interruption going to last? If you think about these two main indexes or indices, that's going to determine your financial impact to any kind of outage. And I also want to just reiterate that when we talk about outages here, we're not talking about strictly unplanned outages, but also maintenance activities. Sometimes you do have a system, a facility turnaround or shutdown so that you can do all your maintenance at the same time in order to mitigate the amount of outage time in any given year or time interval. So here's some terms that we're going to talk about. Availability. So reliability, the word reliability is the exact opposite of probability of failure. So if you have a 10% probability of failure, we would say that you have a 90% reliability factor in your system. Availability is a little different because availability takes that reliability factor and adds in downtime to determine how much in a percentage of time your system will be available to provide sufficient power to your operation. The failure rate is one of the main features to the calculation, is the typical number of failures per any unit exposure time. We're going to talk mainly in failures per year for a specific component and or system. Mean time between failures, that's an index of how often do failures occur, how much time is in between failures. It's a calculated value based off of your failure rates and such. Then you have mean time to repair, which is your average time to get that component or that system back in full service after you have an outage. These are some of the key values that go into a calculation. So what we do per the Gold Book in order to determine the reliability or availability of a system is we're going to follow this cut set method. It's called the minimal cut set method. Essentially, a cut set it can either be a component or a system of components or any collection of components that if you remove that set or that component from your system, you're going to lose your load. So you can have multiple types of cut sets. You can have multiple orders of cut set. So we're going to talk about first order. A first order cut set is a single component. So as an example, I'll put in here, if you have a radio fed system that has one power transformer that supplies, say, an MCC with some motors on it, if you lose that transformer, you lose all the MCC, you lose all your load. A single transformer failure in that instance would cause an outage. So that would be considered a first order cut set. A second order cut set would be any cut set that has two components. So for instance, again, I have an example here. If you have a transformer feeding a MCC and you have a main tie main system, so you have redundant transformers on either side, you lose one transformer, but then say your tie breaker trips, well, then you're going to lose one side of your bus, and that's going to be considered an outage. So that would be an example of a second order. Obviously, this can go as far as you want it to go. We can have third order, fourth order, et cetera, depending on however many combinations of component failures will take you out of service. Well, we don't want to go that far into it because it can go to infinite orders. So what we're going to do in the case of the IEEE Gold Book method is we're going to determine what the lowest order cut set is, and then we're only going to consider the next cut set above them. Anything beyond that is really going to be negligible by comparison when it comes to calculating your availability values. So for instance, if you have first order cut sets, you have one component that will take out your entire system, then we're only going to look and evaluate at first order and second order cut sets, okay? It's important to know that when we talk about a cut set and we talk about a second order, for instance, each component may have its own failure rate, but if you have two components in one cut set, they both have their associated failure rate. There's a calculation where we're going to pull them in as a system and determine what that failure rate would be. If it takes two components to give you an outage, if they have to be both a failure or taken out of service simultaneously to cause an outage, it's less probable that you're going to go down as it is if it's a single component. So what information we need before we start this study? Okay, well, depends on the type of equipment. It depends on the type of failure mode you're talking about. Okay, failure modes can be, it can be a partial failure. It can be a temporary failure. It could be a permanent failure. There's a lot of different ways you can consider that. So your system as a whole, you may have a backup system. Say you have a generator backup. In a lot of cases, a backup generator may come online within 10 seconds. They may have a delay. After a 10-second outage, the generator kicks on and then you can load up. That's going to impact your values. If you don't have that, it's going to take longer for it to be restored to service. That's going to factor into our calculation. Another thing would be maybe if you have a circuit breaker trip and it's just an overload trip and you're going to go and you're going to reset it real quick. Well, that's completely different than having a circuit breaker that blows up, for instance, where you have to pull it out of the system and replace it with a new one. So there's a lot of different pieces and parts to this calculation and to this the philosophy behind the reliability determination. So we could have permanent forced outages, things that require a repair or replacements. These are going to be a long-term type of outage. And then you have your transients, which are things like an overcurrent trip where they can be reset. Okay, so that's how we determine what types of failures we're going to be analyzing here. For protection components, you can have a whole string of different things that can happen. You can have a circuit breaker that doesn't close when you want it to close, or you can have a short circuit trip that causes a trip of your system, right? There's a lot of different ways that a protection component can fail. And there's also a lot of engineering design that goes into preventing these things from taking unnecessary outages. So some of these are going to be a little bit different because when we're talking about protection components and failures that happen because it's a response to an event, the only time that's going to happen is when it's called upon to act. That's not exactly the same type of failure rate as a component failure rate based off of a mechanical failure or just aging, okay? So the point of this is not to know each and every one of these types of failures. It's more to understand how many different parameters are out there that you can consider when you do a reliability study. Because a reliability study can be as complicated as you would like it to be or as simple as you'd like it to be. Of course, the more complicated, the more accurate it's going to be. So here's some common failure modes that we can talk about. You have insufficient device ratings, you have nuisance trips because you're not coordinated properly. You might not have sufficient grounding, and so you might be subject to some transient voltage spikes, surges, things like that. You have a lot of other things that I call risks to reliability, which while, reliability might be something concrete and calculated, lack of maintenance, for instance, will cause premature failure of a component. If you're not coordinated with your protection components and your components don't operate in the correct order, you can take outages that were not intended to clear a fault that's on one component. There's a lot of different things that go into reliability that we can measure, and then there's things that we cannot measure. This is kind of an alarming table here. If you look at it, many people don't really think about this too much. In the electrical world, we're used to hearing things like, 30 or 40 year design life of equipment. But if you look at things like generators, it's got a wide range of the expected useful life, 5 to 20 years. That's because per all these references that are listed on the bottom in their experience, in a lot of cases, generators may not be exercised like they're supposed to, and so when they're called to operate, they don't. Look at a UPS system. A UPS system that's a battery-backed power system. You have a lot of components that just do not last very long, okay? These values may be averages taken off of real historical data, but if you provide proper maintenance, you can make sure that you're on the higher end of those values. So there's a lot of room for component failure out there in our electrical designs today. Historical data is typically what you're looking for. Some bigger companies and companies that have a lot of records of their maintenance and their failures will have their own failure rates, say based on like a circuit breaker. If they say it's a medium voltage circuit breaker, historically they fail this many times per year. And if they have that data documented, we can use that as part of their study, because that will take into account how well they maintain their equipment, how often they cycle their breakers, how often they do the things to improve their own reliability. If you don't have that information, you can refer to the IEEE Gold Book, which will have information in it from back in the 60s and 70s. What I'll tell you is that the Gold Book information is failure rates are a lot higher than real world failure rates by companies that are maintaining their equipment. So it's always better to have your own data if you can. Sometimes you might want to consider whether or not you're in a harsh environment, because if you don't have equipment rated for a harsh environment, say a corrosive environment, then maybe your equipment might not last so long. And whenever we're doing one of these studies, we always want to consider scheduled maintenance time as well before we calculate an availability. Keep in mind that when we're giving you an availability value, it's relative to some other study. So we might be comparing two systems to see which one's more available than another. The values that we discussed before, the mean time between failure or the mean time to repair, this is all information that you should be able to get from your maintenance records, okay? If you cannot, these are also provided in the Gold Book. So if we're going to calculate it, some of these values that you see, some of these are the words we've talked about, and I have a little example here that shows you about, how you calculate these values as you assemble your data. Keep in mind that each one of these values is not necessarily just for one component. It might be for your entire system as a whole. So we have our formulas here, and I do have a quick little example for a single component failure. So in this case, we have mean time between failures is 10 years. So we have a component that fails every 10 years. So what would you expect your failure rate to be? Well, 0.1 failures per year. That's pretty obvious. Mean time to repair for this particular device, we're going to say is 48 hours. So when you calculate your reliability value, the reliability calculates out to be 90.48%. What that means is, if you look at the very bottom, it's the exact opposite of your probability of failure. You have a probability of failure of 9.52%. When we take these values and factor in the time that we're out of service, we go in and we have what's known as the availability. And if you look, the availability number on this one component is actually very high. The reason it's high is because even though it may fail every 10 years, the outage time is only 48 hours. So on average, you're 99.945% available on that system for that component. So we're going to look at a couple different examples here just to compare a series system, which is a single fed radial system shown on the left, and a parallel system on the right, keeping in mind that for the purposes of this example, this is a fully redundant supply, meaning on the right in the parallel system, the MCC loads only require one of those two transformer feeders in order to operate. So when we want to do the series system, we're going to do the cut set method. We only need one order here. We're not going to have a second order cut set because any one of these components fails and we lose our system. Okay, so this is a very straightforward calculation. So our first order failures here, we have our switchgear, we have our low voltage and medium voltage breakers, we have our low voltage MCC, and we have our transformer. If any of those fail, then we're not going to be able to produce out of this MCC. On the bottom left, your reliability, again, a percentage, and your availability being a percentage, the calculations are pretty straightforward. For each component, R1, component R2, component R3, these are your individual components. And as you can see, the calculation is you multiplying their reliability percentages and their availability percentages together. Whenever you multiply percentages together, we all know that percentage will start to decline significantly. Okay, and we're going to do an example calculation here in a second. By comparison, in our other system, parallel system, we have two first order failures, which would be the medium voltage switchgear or the low voltage MCC. We also have second order failures because we have two branches that are fully redundant. Okay, so we have 6 combinations that could occur and those 2 branches that could cause a failure. So this is how we determine what our failure modes are. On the bottom left, we're going to calculate our RP and our AP, which are for parallel. And when you see S1 and S2, what we're doing is we're taking the RS and the AS values from the previous slide for our series system, and we're putting them in parallel. And this is how we determine the overall parallel system availability and reliability. We're going to take an example and we're going to calculate out these values. So here's series versus parallel. For the purposes of this calculation, we're going to ignore the medium voltage switchgear and the low voltage MCC. Let's just ignore those components and focus solely on the feeder, the transformers and the breakers. For the series system, given these arbitrary values I put in here for reliability and availability, as you can see on the left, the series system, the reliability is 94.1% and the availability is 97.4%. The parallel system, as you would expect to be much higher, is 99.65% and 99.93%. So one of the first observations some people may make when they see this is that those percentages are not that different. They're only off by 2%, really, 2.5%. So is it really a big deal? Well, let's take a case study here. Let's say that the production on the systems that we saw, that low voltage MCC, is $10 million per year. That's how much the loads produce for this given system. So let's apply that to our calculations that we have on the bottom. We can see that in our series system, based on the availability number, we are producing $9.74 million per year. So we're experiencing $260,000 in losses per year. On the parallel system, we are now experiencing $70,000 in loss per year compared to the series system of $260,000. So we are now netting $190,000 extra per year because we decided to install a parallel redundant system as opposed to a series system. What's the nicest part of something like that? That $190,000 probably is enough to pay for that system to be installed in the first place, and you can recoup the money from that installation in the first year. And beyond that, now you're talking net profit of an additional $190,000 a year. So while those percentages might be rather low to look at, when you apply them to an actual system and you're looking at actual bottom line dollars, it can make a significant impact. So doing all these calculations, performing these things are not easy. Okay, in the old days, we had to do this by hand. We had to use the gold book. They had, they have so many iterations that you're talking about, so many configurations. If we're talking about a major complex system, in some cases, you might have tens to hundreds of components in one system that you're evaluating. So this is a very highly iterative process. It's not very efficient. Okay. Then we have to consider all this, the maintenance downtime, plus the failure rates, all the different types of failures, et cetera. So there's a lot of things going into this calculation that's going to make it very difficult to do efficiently. So it's a very expensive exercise. So what tools did we have to do these kind of calculations? Well, there's a gold book. You can do it by hand. I've done one of these myself before, and it's not very efficient. They came out with a calculator tool from the gold book. Okay, it's got many, many, many cells, many rows, many columns, and it takes a lot of time to fill out. It also has a lot of its own limitations based off of functionality. Okay, it's not the easiest thing to do either. Well, now in the recent years, we now have a third tool that is making our lives much easier when it comes to calculating reliability, which is electrical modeling software. Okay, we use electrical modeling software in a lot of applications for short circuit calculations, arc flash, load flow calculations, and that sort of thing. Not only for efficiency of your system and calculations for capacity, but also for safety. So now that we have software such as SKM or ETAP or Easy Power, that we build a model, the intention is to have this model that's evergreen, that we constantly update so that we can always plan our infrastructure upgrades and any kind of additions and subtractions. We can get a really good look at what our electrical system's doing. If you're performing these studies and have a good model, now the softwares allow us to add reliability data to the library, and it'll calculate all of these things for us. So here's a quick example of a software calculation that's been performed before. This is the primary distribution at a refinery where they had 3 feeders that fed the primary switchgear. And I mean, this system is huge. This is just a small snapshot of the top part of the system. So what we did was we got the data for the library, the component failure rates, we got the time to failure, between failures. We got all that information and assigned it in a library to each component in our system. Once we pulled it into the components in the system, ETAP did everything else for us. And it produced a report that looks kind of like this. So if you look at this report, we're looking at 3 specific buses that have component data assigned to it. If you're wondering why the 4th bus does not have any data, it's because loss of that bus does not result in loss of production, okay? So they could afford to lose that without losing any money. The other 3, however, they're going to lose money if they drop offline. This is a great example because if you were to want to plan out a new infrastructure upgrade project to improve reliability, I think it's pretty obvious from these results which one you want to go with. The second one, SPB4A, has an E-cost, which is your losses, of $138,000 per year on average based off of the reliability calculation, as opposed to the other 2 buses, 6A and 3B, which are less than $10,000 a year. This will help us look at our system and say, where do we get the biggest bang for our buck? Well, let's do a reliability upgrade on system 4A, and we can get that number down significantly. And every bit we lower that number is more money in our pockets for our facility moving forward on a yearly basis. So this is a great tool for us to use. So now that we've talked about that quickly, I'll just go over, this is going to be very high level. What do we do to improve reliability? What do we have at our disposal? So I'm going to give you a couple just quick little active and passive solutions, as I call them. An active solution is something that we can actually measure with the calculation. We can come up with a concrete calculated value and see benefit. The passive solution is more of something that doesn't necessarily go into the calculation, but we know inherently will improve our system reliability. Active solutions, parallel feeds, adding generator backups, backup systems, transfer schemes, those are important. Stability designs, load shedding systems, so that we can instead of taking a total loss, we can only take a partial loss. That's going to improve our bottom line at the end of the year. Voltage regulation, making sure our voltage is efficient and that we're not going to suffer a dropout of load because of a little fluctuation in voltage somewhere. All of this will help our system out. We can look at our primary distribution design. These are just some different ideas that are out there and that are used today. You have ring bus design where you could take any one of these breakers offline and still fully operate, so you can reduce your maintenance time, downtime. The second one and the one in the middle, you're talking about a breaker and a half scheme. It's a little more expensive, but you can take more than one breaker offline and still operate without loss. And then finally on the right, you have a double bus or double breaker configuration, which is a full redundancy. These things are very expensive, but they're also going to significantly improve your reliability. Modernizing equipment is important. This is our typical, what they call a bathtub curve. The observed failure rate, which is comprised of 3 components. You have your infant mortality, you have your wear out failures, that's just common error, aging, and then you have constant random failures, things that just go wrong. And all together, that puts a failure rate that forms a bathtub. When you do your calculation, if you're calculating based off of old equipment, you should be considering this and using, aged failure rates. So replacing older equipment will put us in the better part of that curve. Passive solutions, I talk about maybe let's spec some higher rated equipment, because a higher rated bus, for instance, or a piece of copper, if you put the same amount of current through it, it won't cause as much heating. And we all know that heat can be really devastating to equipment. We can monitor our systems. We can do gas insulated equipment. Gas insulated equipment is great because all of your key components are in an enclosed atmosphere, not subject to external particles. Making sure our environmental ratings are correct, making sure we're rated for that corrosive atmosphere. Performing maintenance is key. Doing our ultraviolet inspections, looking for heat. Following NETA MTS, which is our maintenance standard, following all of those protocol are key to improving our reliability of our system. Exercising generators and breakers, for that matter, are important. System design, there's ways that we can reduce the amount of faults that we have on our electrical system by installing what's called a high resistive ground system. It virtually eliminates the chance of an outage from a ground fault. Doing things like zone interlocking protection and such is more to prevent nuisance trips from your protection system, okay? Electrical modeling, of course, is a big thing, because by having a evergreen electrical model, we know what our system looks like, what it's doing, and we can look for all of these potential failure points. And now that we know we can add the reliability data, we can do some calculations and determine where our improvements can start. So these are all great passive solutions to improve our reliability. So in summary, it's critical to look at reliability early on, as early as possible in a greenfield environment. And if you're talking brownfield, meaning an existing facility, it's never too late to look at reliability and plan some infrastructure upgrade or improvement. In a lot of cases, we'll use the software and we'll come out with these e-cost reports, and we'll prioritize systems in a facility and say, okay, well, this one will give you your biggest bang for your buck. If you start working on this area, we can save money right out the gate. And in a lot of cases, the project will pay for itself within a couple of years. And of course, maintenance, without question, is one of the most important parts to reliability, and that's applicable not only to electric components, but also to every component, whether it be mechanical or any kind of other process. So with that, that was an overall summary of reliability, electrical reliability specifically, and some of the things that we can do to help improve our systems and keep them running more efficiently. So that's all I have for this presentation. I certainly would open it up to any questions that anybody may have.
Thanks, Sid. We do have some questions coming in. So our first one from Salim Alex Savalon. Are there any pre-established recovery time objectives for when the power goes out?
Well, recovery time for when the power goes out really depends on the application. Some systems can handle a temporary outage, whereas some systems cannot. So it's hard to answer that without knowing a specific application.
Looks like that's the only thing that's come in. So everybody out there in the audience, you've got an expert here, so send in some questions. Well, guess we'll give it going once, going twice, going 3 times, and I don't see any more questions coming in. I think you must have done such a thorough job that all the questions were answered, Sid. So thank you very much. And with that, I'll turn it over to President Gary DeLita to close the meeting out.
Yeah, thanks, Paul, and thanks, Sid, and for the presentation. Yeah, not much left to say. I just want to, a reminder that our next meeting is going to be another virtual meeting on Monday, March 1st during the lunch hour. So look on the website for registration on that. And then again, targeting a return to our in-person meetings in May, the first Monday in May at the North Center, which we did, I think, last November. I think everybody liked that place. And then, like I mentioned earlier, a lot of events coming up here in the spring. So check the website to see how you can register to participate in those events. Or if you want to volunteer, I think we have committee chairpersons' names on the website. So if you want to volunteer to help out at any of those events, please feel free to call the committee chairs or committee persons. And other than that, I'm going to make a motion to adjourn and get out of here and get on with the rest of our week. Yeah, motion to adjourn. Anybody?
Seconded.
Motion to adjourn. Seconded.
Thank you. The meeting is adjourned. Thank you all.
Thank you, Gary.